Shut up and sit down.
Hi, I'm Peter McTavish. Welcome. We're doing 2013 B-2, which was requested here in this comment. And it's a nice axonometric question. I'm surprised I haven't done it already. I checked through the playlist to see if it's there or not, and it isn't, so we'll go through it now. So we are drawing the axonometric axes X, Y, and Z, and the isosceles triangle ABC first. Then you're drawing the elevation and end view, orientated as shown, and you are completing the view. So we'll do that first, and we'll focus on C then. So look at the question. They give you so much information in axonometric questions that even though it's higher level, like it's practically done for you. Again, most of the solution is there in front of you. You have your elevation, you have your end view, you have most of the axonometric done for you here in the center. So it says incomplete diametric. So it's showing you your angles 110, 110, and then your length here of 7 meters. And also we have our scale 1 is to 100. So the AB length of 7 meters is what's going to give you where A and B are, the distance down from them. And then we can do our angles here to find C. Okay, so that's part A done. We have our axis X, Y, and Z put in. We have our isosceles triangle ABC put in. So the angle is 110 degrees. So using the adjustable set square there, I was able to draw the 110 degrees both sides for X and Z. Then perpendicular to, so the BC line is perpendicular to the X-axis. So draw a perpendicular line up until you hit the Y-axis. That gives you C. That completes your triangle. Next it says draw the elevation end view orientated as shown to complete the axonal projection. So basically what you're doing is drawing the true shape of this triangle here on the right hand side for the end view, true shape of this one here for this section here, for the elevation up here on the left. Look at the question. They're giving you the answer. So we're projecting, let's say for the end view first, we're projecting Z up and continuing out. We're projecting up B and C, same angle. We're drawing a line here parallel to BC. We're bisecting that line, finding a semicircle here. When the semicircle cuts the x-axis, that's your point here for your view. That is the corner, and that's our angle, and we can draw in our end view. Same thing with the elevation here. So I'm going to go through this elevation and plan, elevation end view should be straightforward enough. So I'm just going to go through the elevation quickly. So now this here is the baseline, or the XY line for our end view, and that's your vertical. So this is horizontal and vertical angles for the end view, and we can draw it in there now. The only difficult about the end view is look at where we're going to end up finding the center point for the radius 4 meters. So it's radius 4 meters, therefore the length out here will be 4 meters or 14 mil with our scale. Draw that up till you find your line that is parallel to the BC line here. Where it meets it, that is your center point, and then we can draw it up. Height wise, then we know that this point is coming straight up. We're going to go 1 meter out parallel to it, and where it hits our curve, that's how we know to go back horizontal. I'm just going to set up the adjustable set square now to these angles here so that it would draw quickly. Now it's happy enough to draw that end view in strong because it's far enough away from our axis here that we won't have overlapping views. So next is going to be the elevation. The elevation, you have the width. The height is clearly got from the end view because they're not giving you height, but we have our height here. So we use that height then from the elevation. The elevation is exactly the same setup as the end view. Project out your points, put in your parallel line, bisect, and so on. Exactly the same as this. So I'll fly through this one. Okay, so that's the elevation done. Now, drew them strong as well because I'm pretty sure that we have enough space that we're not going to interfere with the axonometric in the center here. So what I'm going to do now is label a few of the points on our end view here because that's where we see the most detail. And then I'm going to label them in the elevation too. and then start projecting now for axonometric view. Okay, so I've labeled points there in the end view, just A to E, and you can see that A, we're just doing one side, they're the exact same on the opposite side. I'll do one side first. So A and D is at the top here, or A and B is at the top, C and D is at the bottom, and E, we have to find the height for E. Mark here, and I project it across the other side as well. So you're projecting down same angle as your Z axis from the elevation, same angle as your X axis from the end view, and where they meet gives you your points here in your axonometric view. Now, that's the majority of our axonometric view done. Also, this is a goal, so we're going to have some hidden detail in at the back here, or not hidden detail, but we'll see a bit through it in a minute. But next thing we're going to do is we need to see our curve. So for axonometric, whatever way you divide up the curve in one of your orthographic views, you must do the same in your other orthographic view. So what I mean by that, if you divide up the curve 30-60 here in the end view, how exactly are you going to do that over here in the elevation? So what you need to do in this case, we need the curves going from E up to A. So in order to see it here in the end view, it's vertical. I need heights. So what I need to do is do a range of heights. We don't need lengths across here. We just need heights. Because once we get the height, we can bring the point down, bring the height across here from the elevation, and put in our curve. So what I'll do is I'll measure this here roughly, see what it is. Put in maybe a couple of 10s, 5s maybe. Whatever measurements I use, I gotta use the same in the other view, and then I'll project the two down, and I'll do both sides. Okay, and that is part B done. So we found our points here, we found our heights in the end view, put the heights in the elevation as well, project them down, and then find the points. Now, this section here, as you can see there is a bit of a mistake, as in I'm projecting C down, should be meeting there, but also it should be vertical line down from B. So I just went with the vertical line. So sometimes like these questions, my setup here is a bit awkward as well, but if your T-square is off a small bit, if your angle is slightly off, you're just with Z-square, or you're not projecting down exactly parallel, they can tend to be a small bit off, but you know that has to be vertical line, so work off that. So part C, it says a ball is positioned on the ground at point F for a kick. Point F is 9 meters away from the goal line and is located in the direction shown. The path of the ball after it is kicked is a parabola which reaches a maximum height of 6 meters, having traveled a horizontal distance of 6 meters. By drawing the parabola in the end view or otherwise, determine whether the ball goes under or over the crossbar. So it's giving you a random point here in the axonometric, and it's showing you F is out this direction, so in front of the goal. Now it's mentioned there the end view for a reason, because that point on the goal line here, point C here in the end view, is a point view of the line. So that is our point. No matter where it is on the line, it will always be on that point here in the end view. So we need to go and find F, which is 9 meters away, straight up here. So that's our point F, just to zoom in on that. So it says the path of the ball is a parabola which reaches a maximum height of 6 meters, having travelled a horizontal distance of 6 meters. So that's very straightforward. We're drawing a parabola here. Its vertex is 6 meters in and 6 meters up. We'll draw the parabola, we'll project it over to the other side, and it will determine then whether or not it goes under or over the crossbar. Also, it says ignore the radius of the ball because we're just worrying about the projected path. So there's your parabola. So it's a bit messy here because I went 70 mil instead of 60 mil, or 7 meters instead of 6 meters. So my vertex is on this line here, and I already drew it over there. So that's why it's a bit messy here. But once we find our points, once we find half of our parabola up to the vertex, it's symmetrical, so the same distance far side for your points. Project them across, and as you can clearly see, now I added on the fourth one here to make sure that our crossover had a good curve. So you see there, it clearly drops underneath the line. And that's part C done. So that's all I asked you to do, just show it by drawing it. So that is the full question done. So as always, hope this helped. If it did, leave a like. Best luck in your exams, and we'll see you in the next one.